Okay, let's talk about integrals. So this first integral is going to be pretty simple. It's just the integral of vt plus sine of t over 2 minus t cubed plus v squared dv. And the only thing you got to make sure you look at here is that you don't differentiate in terms of t, since it's dv, integrating. We're integrating in terms of v. So this integral will equal, it'll be 1/2 v squared t plus v sine t over 2 minus vt cubed plus 1/3 v cubed plus c. And that is our final answer. Alright, moving on, let's try this integral, which is going to be the integral of 4x times e to the x squared plus e to the x squared dx. And so the key thing here is we're just going to try to use u sub, because off of regular methods, it'd be a little trickier. So for u sub, let's define our variable u. Let's set u equal to e to the x squared, as we see that happening a lot. And so then, therefore, du must equal 2x e to the x squared dx. So let's substitute everything in. So this equals the integral of 2 times e to the u du, as this part just represents du. And so once we have this equals 2e to the u is, we already know how e to the u integrates. And then just plug u back in and you get 2e to the x squared as your final answer. Alright, let's try something a little trickier. We have the integral of tan inverse x over 1 plus 1 over x squared. So let's just rewrite this integral. I'm going to write it as the integral of x squared tan inverse x over x squared plus 1. So we just multiplied the top and bottom by x squared over x squared. Sorry, I forgot a dx. And from here, it might look like it'd be easier to use u sub, since you have your tan inverse x, you have your x squared plus 1. And you could go about it that way, but I think it's easier to just go straight to partial derivatives or partial differentiation. So let's just say that the tan inverse x, that's going to be u. And then x squared over x squared plus 1, that's going to be dv. So we're going to solve for v. V equals the integral of x squared over x squared plus 1. Or actually, I'm going to write it like this, plus 1 minus 1 dx, and that's going to be the integral of 1 minus 1 over x squared dx, which is the same thing as just x plus 1 over x dx, or sorry, not dx, 1 over x. And so if that's going to be what we have there, or sorry, this is 1 plus x squared, isn't it? Yeah, sorry, not x plus 1 over x. This is x minus tangent inverse x. That's my bad. So if we have that, we can rewrite it by integration by parts, or at least, sorry, this integral by integration by parts, this one. And so it's going to be equal to x minus tan inverse x, which is our v, times u, which is tan inverse x, minus the integral of x minus tan inverse x all over the the derivative of tan inverse x is 1 over 1 plus x squared. So let's just rewrite that here really quick. We have x tan inverse x minus tan inverse x squared minus the integral of x minus tan inverse x all over 1 plus x squared. And so this integral we're going to split up into the integral of x over 1 plus x squared minus the integral of tan inverse x over 1 plus x squared. And from here, we can use u sub on both of these actually. We could just set u here, u equals 1 plus x squared, du equals 2x. So this portion will leave 1/2 ln 1 plus x squared after integrating. And then this integral, we're just going to set u equal to tan inverse x. So du equals 1 over 1 plus x squared. Sorry, these should have dx's. And from there, we can say that this portion equals minus 1/2 tan inverse x squared. And so we're going to just plug this all the way back in so that we get x tangent inverse x. These two are going to combine to form minus 1/2 tangent inverse x whole squared on minus 1/2 ln 1 plus x squared. And sorry, plus c. And that is going to be our final answer. Let's do one more. We have the integral of the square root of 2x squared minus 4x minus 7 dx. And let's use trig sub for this one. So if we're using trig sub, we want to get it in the form of square root x squared minus a squared, or a squared minus x squared. But here we can clearly see that we want to make it x squared minus a squared. So we can try to factor this around, right? And once we factor, we get, complete the square. We get 2 times x minus 1 squared minus 9. And so this is the same as the integral of root 2x minus root 2. I just combine those. And you're going to square this, minus 3 squared. So now we can set up our trig sub. Or before that, maybe we should just set up our u sub just to make it a little nicer. So we can just say u equals root 2x minus root 2. And from there, we see that du equals root 2 dx. So that this integral is the same as 1 over root 2 integral of u squared minus 3 squared. And let's now set up our trig sub. We're gonna say, u is the same as 3 secant theta, and that du equals 3 secant theta tangent theta d theta. So from there, let's rewrite everything in terms of theta so that we get 1 over root 2 times 9 secant theta tangent squared theta d theta. So from here, I'm going to just take that 9 out. So let's just move that here. And let's get rid of this. And here we can just turn everything in terms of secant, right? So this is the same as 9 over root 2 integral of secant cubed theta minus secant theta. So let's first focus on this part of the integral, secant cubed theta. If you know your reduction formulas, this is pretty simple, but I'll walk you guys through it if you want to use integration by parts to just at least prove that reduction formula. So the integral of secant cubed theta, that's going to be homogeneous with considering u as secant theta and dv as secant squared theta. So your first term is going to be secant theta tan theta minus the integral of, once again, actually, secant theta tangent square theta. And we can rewrite this in terms of this. Sorry, in terms of this. So this is secant cube theta minus secant theta. Move this over to that side. Get rid of this. I can actually make this a positive here. And so we get secant cube theta to be equal to, let me write this nicer. This is equal to 1/2 plus 1/2 the integral of secant theta. Now let's combine everything. We're going to have 9 over root 2 times 1/2 secant theta tangent theta. And this will be, we have a minus, we have a plus, minus 1/2 the integral of secant theta. Right? And then from there, we can set this equal to 9 over 2 root 2 secant theta tangent theta minus 9 over 2 root 2 ln of, sorry, this should be absolute value of secant theta plus tangent theta plus c, of course. And then it's all about just plugging everything back in. So we know secant theta is going to be, 3 secant theta is going to be u, and 3 tangent theta is going to be that square root we started with. So this all will, let me just rewrite this in terms of u. This will all be equal to, I believe, u square root u squared minus 9 all over 2 root 2, and then this will be minus 9, let's put this all over actually, ln of secant theta we said was u, so u over 3, sorry about that, and then tangent theta is square root of u squared minus 9 over 3. All of this plus c. Now we're just going to plug everything back in terms of x. As we said, u was root 2 times the whole value of x minus 1. And so our final answer is going to be, let's see, plug everything back in. And we get root 2 x minus 1 square root, and our original was 2x squared minus 4x minus 7. This minus 9 times the natural log of root 2x minus 1 plus the square root of 2x squared minus 4x minus 7 all over 3 all over 2 root 2, and this is our final answer.